After. Wait. Let's check it out. $100. Huh. Yep. Yes. Excellent. Good, good, good. Good. All right. Huh. So. Right. The moment of truth pretty much I think is done right now. And yeah, let's see. 5 volts. It should work at 12, but I will try it with 5 volts. Nothing works. Probably some wire somewhere. Alright, I will push it to 12 volts right now. And nothing. Huh. Okay. Alright, I'm back to 5 volts because it's safe. And let me look and test everything again. It will take a little bit. Yes. Now I will put it on 12 volts. 10, 11, 12. Alright. So, unfortunately that LED is pretty bright at minimum, at 0. This should be 0. But yes, is one spike that is keeping it alive. And yes, it's working good. The problem was the wire, the LED pins were not soldered. They were desoldered. One pin was desoldered from the LED, and that was the problem. This particular LED is having a little bit of issues with the pins, but if you take care of them. So the PWM is working fine. Alright, let's see. This is my other circuit, and I don't have another. What I have? Huh? No, I don't think so. the minus. And it's working pretty good. Huh? Can you see it? Can you hear it? And the temperature is quite you can hear it. I want you to hear it. Do you hear it? And now it's calming down. Like this. Yes. Yeah, I intentionally leave it. I intentionally leave the sound on for you to hear how it's working. And this is the maximum. This is the minimum. But because there are some spikes, this LED is still alive. It should be off like the motor. But what we really want is the motor behavior, and the LED is just there for the show, you know, to tell us yeah, it's pretty good. I like it. It worked from one shot, and now is, let me tweak it a little bit. 12 volts, right? Working splendidly, excellent. The circuit is very good. I will update everything I did here with the module, and this thing will power this thing. This is the actual ventilator here, and what we have here is a test fan. But this is the actual fan that will be drive, and this circuit will be somewhere. I didn't think where to put it yet, but it's working for now, and is for this device that I'm showing you here. So it's working. It's good. Excellent. Thank you very much for staying, for watching, and yeah, it's good. It's good. I'm putting my finger on a couple of components because they are so small. To verify if something is hot. But absolutely nothing is hot. Not even warm. Which is absolutely awesome. Perfect. Nothing is warm. Nothing is hot. Excellent. That's why I use the MOSFET. The MOSFET is... he doesn't care. So yes, I love MOSFETs. Thank you very much for watching again, and I will make another update soon enough. Alright? Thank you very much. Alright. This today I build this module, and it's this is a triac, this is a diac and triac, and it's actually this is my first sample with which this is a testing circuit that I built here. I know it's looking very weird and funky, but I tested successfully. I tested a motor for 220 volts, a DC motor it was. That's why you can see here a rectifying bridge, and those are very little fuses. There are very thin wires, copper wires as fuses. If something will blow up from there, hopefully. But nothing actually blow up ever. Everything was smooth with this circuit all the time. And this circuit, so this was for testing, everything for testing. This big circuit was for testing all the time. And this is actually the schematic of it. And I hope you can see it good enough. And alright. And this circuit is based on this. This guy, I took it from eBay, and I reverse engineered it, and I buy the components myself. I build this one, and today I build another one. This is not for testing. This is actually the complete, not the complete, the final circuit that will drive this module here. Let me actually show you, because this is what I used before, a mirror to actually look in the same time, to look there and see I think you can see something. Can you see something? Yes, this is it. Yes, can you see the coil inside? Actually, you know what? I can take it out and I can show you, but I have to. I have to pause it first. All right, 1 second. So. Okay. And this is the coil. This is the heating coil, which is a bit loose right now because I tested before and it got extremely hot. I don't believe this coil is made for 240 volts. It's probably for a little bit less voltage or power. When it was new, it wasn't this large. This coil wasn't this large. It got larger like this, like you are seeing now. If I'm, you cannot. But if I'm, you can see how large it is. It got that this large because I overheated it and keep it a couple of seconds overheated in my original testings before I mounted it here in this ensemble that you see here, which is with plastics and paper and cardboard. My design. This is all my design, and here is the fan, which is like this. You see, it's very. You see it there? Yeah. So this is how it looks, and this is the purpose of everything. Can I put it back? Usually it's very extremely easy to put it back like that. So this is the coil, and that driver that I showed you, where are you? Here you are. This little driver, which is a clone of this thing here, I by the way, I never needed a heatsink like this guy is having here. I never use it. I never needed it in this testing circuit that I have here. It behaves extremely well. Everything is falling apart here. My mirror is funky. So yes, this is the clone of that, and I just tested it, and I got a very interesting problem here. Do you see a ton of solder that I put here? I was getting some very small, I could hear actually the sparks, very small sparks in that region. Come on. Yes. So here in this point, here is the junction of the capacitor leg. Here is behind this resistor somewhere there. So it's this capacitor and this resistor with one point. That's it. This is the only contact. And the capacitor was very close to this very large pad metallic pad, and I believe because it was not a good separation, it was creating some sparks there, and really not a very good soldering as well. And I decided to blob it to make a very big and stupid blob, and make some create some distance from the capacitor from that pad, metallic pad. And I tested again, and yep, it's working. And I got some smoke a little bit from, I'm not sure from what actually, and the smell was, I couldn't tell what it was. The smell, it was weird. I believe this is I don't know in English. I don't know in Romanian. is this thing? You see, you mix it with water. It's very fragile. It's very fragile. Gips. It's called gips. Gypsum in English. So gypsum. So this is gypsum that you they use in the hospital to put your broken leg into. And this is actually a piece of bandage. It's very cheap, extremely cheap and extremely flimsy and very shitty and very old bandage that I had, and the thing was cracking, and is cracked. Actually, it is cracked. But I reassembled the parts and bandage it, and then catch it in this armature, metallic armature here, and or jig, metallic jig. And yeah, it took me a ton of time to design it, and to think about it, and how to mount it. And I'm working on this project for a couple of years, but I'm not working on it every day. I kind of I was extremely lazy building it, testing a lot of materials, a lot of I also had a lot of bad luck. I'm not sure if this will remain as you can see it right now. Hopefully it will be okay. Hopefully, I'm not a religious person, but for this contraption that I did here, I am really praying that will work. So this is a prototype, what you can see here. It's my prototype. It's my thinking, my imagination, my way of putting it into practice. You know, it's my practical device that I build. Also is doing like this. If you were wondering what this joint point is, so it's a very small angle degree, but I believe is more than enough for what I will need it to. And yes, right now what you can see, what I'm showing you actually right now is this driver for that heating coil that you've seen there, and this is the driver for the MOSFET, that little thing there that I'm pointing right now. Not rusty knife, right? Where are you? Here, exactly there. That is the MOSFET. And all this contraption, all the entire fucking schematic that you are seeing here, and also is having another potentiometer on these pins. I don't remember which one. This, and this, I think. These three. And where are you? I believe, yes, this is the potentiometer that will be there. This circuit is powered from this transformer, and here is the transformer that I took it from a real transformer. And this was this because I am a European, we have different pins, plug pins for the mains, and this is English. Somebody gave it to me, actually from England, a lot of them actually, and I discomplete them, took the case apart and use only the inside, the coil and the transformer, the actual transformer, and this was broken actually, and I managed to fucking repair it. If you can see here, you see this blow up sticker that is there inside there, linked to these two pins, which I later put my own link. Here is my own, you can see this gold link here. This is my old my link that I put it after that. I really believe that this is broken. It wasn't working at all. It wasn't outputting anything here. This is the input, the 240 volts, and it was actually a very small piece, the first piece that the first component of this kind that I encountered, and I searched for it on internet, and I find out that it was temperature sensor. Under this sticker, so basically it was stick to the coil, and that temperature sensor, it was open. The circuit inside it was open instead of being continuous. And then I said, well, fuck it, I will put my own link here, and it worked. And this is the reparation. This is the way I repair it. And this case is made from cardboard. I made it, of course. And I put two screws here. You see? Here. Hole screw. And nothing metallic is touching. And this is the 12 volts for the motor. For this motor here. The fan motor, computer fan motor. And also this entire circuit, the 12 volts from this transformer will go into this circuit, and this circuit I will vary the speed of the motor through that little fucking tiny MOSFET. And the entire circuit is for this little guy there. And I also have a LED there, but that's not very important. Yes, that's it. I don't know how I will make this interface. This is the board interface for this entire device. This is the interface with the buttons. Not with the buttons, with the scrolls, the potentiometers. This potentiometer for the motor speed, and this potentiometer that will be varying the coil heat, the heat of the coil, and if this contraption will not get on fire, because I have a lot of plastic, a lot of cardboard, and then wood. Wood will take fire slower than those two. Those two are very easy to ignite and to. I should not talk too much about this subject, but yes, if I'm lucky, nothing to burn, to burn up. Well, I'm a genius. I hope I'm a genius. All right, this is it. Thank you very much, and see you later. This is it for this update, pretty much. Okay, thank you very much, and see you later.